Nill Bye the Science Guy.
The first of three laws developed by Sir Isaac Newton states an object at rest stays at rest, and an object in motion stays in motion unless acted upon by an unbalanced force. This law is displayed in this example. Cade's muscles in his legs are applying the same amount of force with every step in order to create constant speed. Cade would be standing still unless his muscles in his legs apply the force needed to move. While force can be applied to objects to make them move at a constant speed, an object's speed can change. This is called acceleration. In this example, my friend Jesse here starts out at a normal walking pace. About halfway through the clip, his muscles in his legs apply more force to his pace and he accelerates into a running pace. The more gradual force per second applied, the greater the acceleration. Our friend Jesse is now displaying gravity. As a matter of fact, everything in the clip is. Every object with a mass has a gravitational pull towards its center. If you live on Earth, you are being pulled to the center of the Earth. At the beginning of this clip, Jesse is standing on a ledge. The ledge's upward force is greater than the downward force of gravity, so Jesse is not falling. But when Jesse steps off the ledge, the air resistance pushing up on Jesse is lesser than the downward force of gravity. Therefore, Jesse falls towards the center of the Earth until he hits the ground. Now, Cade is displaying the third law of motion. Every action has an equal and opposite reaction. When Cade throws down the ball bounces downwards because it's being pushed downwards, and then it pushes right back up because the equal reaction is the ball being pushed down, and then it has the equal force being pushed back up. Then the opposite reaction is the opposite direction that the ball goes when it gets bounced back up. Newton's second law of motion states that an object's acceleration depends on its force and its mass. Now, we see Cade. Cade doesn't apply as much force to the football as Jesse does, and the ball still has the same mass between the two tests. So the ball that Cade throws does not go as far. While Jesse, who applies more force to the football, but the football still has the same mass, goes further because Jesse applies more force to the football. If you want to learn a little more about Isaac Newton, please join me on Consider the Following. Now, the first law states that an object at rest stays at rest, and an object in motion stays in motion unless acted upon by an unbalanced force. So, a lot of people might ask, what's the unbalanced force on Earth? So, what is it that keeps things from just going on forever like it does in outer space? Well, a lot of people, gravity is a force, and people don't. So, when Isaac Newton was testing it out, he didn't really know that he didn't know about the vacuum of space. He didn't know because no one had been in space at his time. So he only had Earth to test with, but he still could figure out that an object at rest will stay at rest unless acted upon by another force. An object in motion will stay in motion unless acted upon by another force. So Isaac Newton figured out that an object in motion will stay in motion, and an object at rest will stay at rest unless acted upon by an unbalanced force without the use of space. And I find that interesting. Thank you for joining me on Consider the Following. So tell us about motion.
I study it.
What's your favorite part about motion?
It's everywhere.
Can you describe the motion? Can you see an example of motion right now?
No. I mostly study motion on the moon.
Tell us about the moon.
There's not that much gravity there.
Oh yes? Is there anything else about it?
There's no wind.
There's no wind. So what does that create in terms of motion?
I don't know. Okay, wait. What am I doing right now? It means that when items drop, they won't be affected by it. So, take, for instance, a hammer and a feather. The feather on Earth would drop a lot slower because there's a bunch of air holding it up.
Yes.
But since there's no air to hold it down, the law of inertia and such is a beautiful thing when it falls, and the motion and velocity of the acceleration.
So what happens then when they fall on the moon?
Then they fall at the same time because the law of inertia and energy and the xenomorphs don't interfere on the moon, though.
What is the law of inertia? Can you show me an example of law of inertia right now around this backyard?
Yeah.
Like what?
Let's take this phone and this hat. Totally different masses.
Yes.
Drop them from the same height. They hit at the exact same time.
Why is that?
Yeah, I just explained it.
No.
Are you not listening to me?
Which one weighs more? Which one weighs more, though?
This one weighs more. Doesn't matter, though.
So, what you're trying to say to me is, like on the moon, because do you think those two objects have similar mass?
No.
They do not. Then why do they fall at the same time?
Well, part of it, the xenomorphs have been really cool lately. They're not messing with anything.
Actual science, please.
This is actual science.
Shut up.
Xenomorphs are real. I don't think they really fight predators, though. They're like totally different galaxies. I don't know why they made that movie.
Aliens. Thank you for your time, Mr. Scientist. Sir. I don't actually know your name.
I'm
Thank
sorry.
you very much.
I'm getting a ride from my mom. I don't know how to drive.
Goodbye, sir. Come back anytime. By that, I mean get out of my house.
There's no.
You're trying to do a really bad Matthew McConaughey right now.
There's no gravity on the moon.
No, it's the other way. There is gravity, no atmosphere.
So there's no gravity on the moon. Oh my god! That's the third time! I'm horrible at this. I'm horrible at this. Ask me more questions.
Do you have the time to listen to me whine about motion and everything that's like it? I am one of those scientific fools, neurotic to the bone, no doubt about it. Sometimes my movement gives me the creeps. Sometimes forces play tricks on me. It all keeps making sense. I think I'm too observant. Am I intelligent? Well, I don't know. I went to my lab to run some movement tests. They show me reference points of motion. I went to a friend. He said there's also friction. So I tried to see where the friction is.